All right, so for the first one, we have a magnitude of 5 newtons, right? So what we're gonna do here is the vector A is equal to vector B, which is equal to 5 newtons, right? So now we're gonna do A plus B plus C is gonna equal us to 0. So for A, what we do is we do AX is 5 cosine 38 degrees, which gives us 4.33 newtons. For Y on the Y-axis, we're gonna do, A on the Y-axis, we're gonna do 530, which is 2.5 newtons. Now for B, we do B of X is equal to negative 4.33 newtons. B of Y2, right, is equal to 2.5 newtons, right? So what we must do is the vector A is 4.33 initial plus 2.5 final, and the B is negative 4.33 initial plus 2.5, right? So let's do A plus B, right? 5J because of the 5 newtons is equal to C, right? So we get C equal to negative 5 to is going to equal us to 5 newtons because this is radicalized, right? So the direction of it is below the horizontal, and the only one that's below the horizontal is this one right here. All right, so for this question here, we're gonna find the final speed of block A and the amount of potential energy that was stored in the compressed spring. So we are given the mass of block A, which is 3 kilograms, and the mass of block 2, which is 6 kilograms. And M2 has the speed of 1 meter per second, right? So we're gonna do M1 V1 plus M2 V2. I'm gonna plug them in. So it's gonna be 6 for that one. And then a 1 here. And that's gonna equal to 3. And we don't know what the V1 that's what we're looking for. So 6 times 1 is 6. And then 6 divided by 3. And that's gonna give us negative 2 for the velocity. And our only answer choice is gonna be this one B right here. Alright, so here we have a block with a mass of 2 kilograms, right? So the mass is 2 kilograms. And we have the distance when it springs, when it compresses, is 0.20, right? So, and the distance is 1 meter. And we have the K constant, which is 200. So we're going to use the law of conservation energy for the system. The coefficient of kinetic friction is this. Which, as put in the equation, we have, these are the kinetic energies, right? And U is the potential energy. And this is the work done on the block after it's released off the spring. So we're gonna put it into the equation. We're gonna have 1/2 times the 200 newtons 0.20, which is the distance, right? And then we're looking for the coefficient, so that's going to be right there. And then put in the kilograms, which is 2 kilograms. Wait, this isn't that, that's multiply. 2 kilograms. And then obviously the gravity coefficient. And 1 because of the distance of travel. So then, since we have that part of the equation, we're just going to, just put it all over. This is all going to equal to 4 joules, right? Over the 2 kilograms, 9.8, and the 1 meter, right? Then that is going to give us 0.2. So that's our answer, B.